Subscribe now and press the bell icon. Never miss an update.
Hello guys, this is Netra P Chand. Welcome to my mathematics class. Let's see today's topic. Today's topic is real number system. But in real number system, today we are going to study using the properties of real numbers. Prove that. How to prove? Okay, it seems very easy one. A b is equal to 1, b is equal to 1 upon a b is equal to 1, a is equal to 1 upon b, a plus b is equal to b plus c is equal to a, implies a is equal to b, a c is equal to bc implies a is equal to b. So you can say this is the left hand work we can do very easily. But using properties, how to do. That's the important thing. That's difficult one, okay. Without knowing the properties, you can't do these questions. Alright. So I'll tell you how to prove these questions, okay? Using the properties of real number. Okay, so let's start. One first. We have AB is equal to 1. Implies we want to remove here. From here, we want to remove from left hand side. We want to remove A. We want to keep only B, because we have to prove B is equal to 1 upon A. So let's see. Okay, there is one property in real number. For A not equal to 0 belongs to R, there exists A inverse, or you can say 1 upon A belongs to R. Okay, there exists, okay, in real number. For every real number except 0, there is inverse of, multiplicity inverse of that number, right? So we can say, okay, multiplicity inverse of that. Okay, if we have a 1, then 1 is the 1, multiplicity inverse of 1. If there is a 2 real number, then 1 upon 2 is the multiplicity inverse of 2. Alright, so using this property, so there exists this property will there exist, okay, A inverse means multiplicity inverse of A belongs to R. Okay, we will multiply both sides on the left, okay, inverse, okay, and AB is equal to inverse into 1, you can write down. Alright, so 1. So here what we have done, reason you can write down. So okay, we have reason, okay, since for A, for A is not equal to 0 belongs to R, there exists inverse belongs to R. R means set of real numbers. So multiplying both sides by multiplicity inverse of A, right? Or both sides on the left, because we have to tell, okay, so both sides, okay, right, multiplying, so multiplying both sides by inverse on the left, okay, because A inverse exists. For A is not equal to 0, definitely here neither A is equal to 0 nor B is equal to 0. Otherwise, okay, if A is equal to 0, you can imagine, okay, 0 times B 0, and if, okay, B is equal to 0, then you can A times 0 is equal to 0, but on the right hand side we have a 1. So this shows that, okay, neither A is equal to 0 nor B is equal to 0 here, right? Now next property here, A inverse dot A is equal to B is equal to A inverse 1, right? A inverse 1 dot 1 into 1. So here, so listen to me everybody, you need to tell the reason. So for the change of any step here, you have to tell the reason. For this reason, how can I write down like this way? So by associative property of real numbers. Associativity is satisfied by the real numbers, right? Associativity property is satisfied by the real numbers. Okay, what is the associativity? If you have any confusion, if we have A times B, this property is satisfied. A, B, C, or so here C belongs to R, C belongs to R, means A, B, C and real numbers, then A, B times C is equal to A times the product of B and C. This property is satisfied for the real numbers. Using this property I have written here, right? Because these all are real numbers, so associative. This property is called the associative property. Okay? Associative property. And now, implies A inverse A, we can write 1 times B is equal to inverse into 1. So how can I write down, okay, instead of inverse dot A is equal to 1, using here here multiplicative inverse multiplicative inverse property. Let me tell you what is the multiplicative inverse property. For A not equal to 0 belongs to R, means, okay, except 0 real number, there exists, this meaning of there exists, symbol there exists A inverse, or I can say 1 upon A. A inverse means 1 upon A here, or such that A times A inverse is equal to inverse times A is equal to 1. This property is called your multiplicative inverse property. This is your multiplicative inverse property. Alright, so I'm going to explain the property also, which property we have used here. What is that property? Okay, so this property is called your multiplicative inverse property, right? Multiplicative inverse property. Alright, so I think now clear what is your multiplicative inverse property here. Here A inverse is equal to 1. This is due to the multiplicative inverse. Now the next line, next step in this question, 1 dot B, we can write on the B is equal to here A inverse dot A, or simply you can write on the 1 upon A. So listen to me here. Here I have written 1 dot B is equal to B, 1 into B. Okay, 1 times B is equal to B, and A inverse times A, 1. So inverse, I have already told you, inverse or 1 upon A is the same thing, right? And here, so how can I write down this one? Which property you have applied? If you have a question, now I'm going to clear it. So here, multiplicative identity. Multiplicative identity property, right? So what is the multiplicative identity? Okay, again, if you have a problem, so see, okay, for A, alright, belongs to R, right? Belongs to R. There exists one belongs to R on the set of real numbers. For all A belongs to R, for all you can say, for all A belongs to R, means set of real numbers. What is this? Set of real numbers. Means collection of real numbers. And there exists one belongs to real number, or set of a real number. So 1 is also real number, right? In the set of real numbers, we have a 1 such that A times 1 is equal to 1 times A is equal to A. This property is called your multiplicative. 1 is called your multiplicative identity property, right? So 1 is called your multiplicative identity, and this property is called your multiplicative identity property, right? So I think now clear. So what is your multiplicative identity property? You can go through it. All right. Now B is equal to 1 upon A. So alright, so we can implies, okay, B is equal to 1 upon A. Hence the proof. So simply, not so difficult. but you have to tell reasons for all. If you will not write down the reasons for each and every line, you are not going to get the marks, right? It's very very important. So how can we write down a b is equal to 1? In general, you write down, okay, a b is equal to 1 directly, b is equal to 1 upon a, or a is equal to 1 upon b without any reason, all right? But how can we do using the properties of real number, how it happens actually? So today you came to know, I think, right? All right. So second question also same type of, you can do very easily. All right. Just exactly other than the first part, this or first, second part also you can do exactly the same way. You have no problem, right? Now third one I'm going to tell you, a plus b here, because here we have used the multiplication properties, right? Properties based on multiplication. Now I'm going to use the properties of real number on addition. Okay, all right. uh, so I think clear. Now I'm going to teach you the third number. So third number, what is the third number? Okay, this is the third number. Solution a plus b. Very interesting question. A plus b is equal to b plus c implies, okay, how we get a is equal to b. In general, what we do, okay, we just cancel, right? But actually, okay, using real numbers, how we get, then we know, right? So what's the reason behind it? Okay, see, a plus b is equal to b plus b. So let's take the b on a same side. Either you can keep on the left hand side, left, okay, left side, or a right side, okay. On the left hand side you can see the b is on a right, and on the right hand side you can see the b is on a left. So let's try to, okay, let's a plus b is equal to, here I'm okay, c plus b writing. So again we have brought here some change, okay. What's that change? So let's explain that change, okay. B plus c is equal to c plus b. I have written this one. So this property is your commutative property, commutative property of addition. All right, this property is commutative property of addition, okay. For any b comma c belongs to R, if any two real numbers are there, then b plus c is equal to c plus b. Order doesn't matter, but you will get the same result. This is called your commutative property on addition, all right, of the real numbers. So now I have used a commutative property. So here I'll write down the commutative property. This is called your commutative property, all right, or commutative law you may say, right? Property, commutative property on addition, all right. And the next, now, so how to remove b? The question is how to remove, because we want to get is equal to, okay, here I think I wrote question wrong, okay. Here we need to, a plus b is equal to b plus c, and we want to remove b. And how to get, okay, a is equal to c, okay. A is equal to c, how to get? All right, so we have to remove b. So see everybody, here we need to write down, okay, b and plus negative b, and is equal to c plus b and plus negative b. You can't just subtract, you have to add negative numbers on both sides, right? See, there exists, okay, so for a belongs to R, any real numbers, there exist, okay, on the set of real numbers, we have, okay, negative a belongs to R. For any a belongs to R, there exists negative a belongs to R. On the set of real numbers, if you choose 1, on the set of real numbers, we have minus 1. If you choose, okay, 10, then minus 10. If you choose, okay, minus 1.5, then we have 1.5, right? So you are going to get, okay, right? For a belongs to R, there exists negative a belongs to R. Okay, everybody? So that's why I have added, right? On adding. So you can write down, okay? For adding negative b on both sides on the right. Both sides on the right, okay, on the right side I have added. Okay, now next property, a plus b plus negative b. You have to write exactly as I've written here. You can't write down, okay, negative minus b is equal to c plus b plus minus b. Okay, so I think you understood. In addition, a, b, c belongs to a plus b, any, okay, for any you can say a plus b plus c is equal to a plus b plus c. We can write down. This property is called your associative property. Okay, by you can write down, okay, we have brought here this change, okay, because of associative law or associative property, you may write down, no problem. And then is equal to a plus b plus negative b. We can write down 0 c plus 0. So again, okay, we have used, okay, another property. Let me explain here. For a belongs to R, there exists, okay, negative a belongs to R such that you may write down, okay, such that a plus negative a is equal to 0 is equal to negative a plus a. This property is called your additive inverse. Your negative a is called your additive inverse, okay, right? So using, okay, additive inverse property, right? Additive inverse property, using additive inverse property. So a plus 0 is equal to c plus 0. We can write down, okay, here, right? This is actually, okay, you have to. So we have written instead of this 0. So how this becomes, okay, 0 due to the additive inverse property. You can say this plus negative of a is equal to 0. Negative a plus a is equal to 0. Okay, this also is equal to 0. This also is equal to 0. This is due to additive inverse property. Now let's see the next line. Implies a plus 0 is equal to a is equal to c plus 0 is equal to c. So this is called your additive identity property. Now I will tell you, this is due to additive identity property. Identity property, right? Additive identity property. So what is your identity property? Let me tell you. If A belongs to R, there exists, okay, 0 belongs to R, such that, okay, a plus 0 is equal to 0 plus a is equal to a. Here we have written a plus 0 is equal to a, c plus 0 is equal to c we have written, right? So a plus 0 is equal to a, 0 plus a is equal to a. So this is called your additive identity property, right? This is also the properties of real numbers on addition. Okay, so now I think clear. Now you have no problem. Now we have done this question. Okay, proved, okay, a is equal to c. Oh, hence proved. Now I think clear, absolutely clear. Now no problem. Each and every property, whatever we need, okay, here, whatever we have used here, explain, right? So I have not skipped even single line. Properly I have explained. So very important questions for you, right? Next, okay, now question number 5, how to. So I'll tell you, right, how to do. It's very simple, just exactly just like, okay, this we can do, right? So see here, firstly you can multiply C inverse, right? Multiply on both sides by C inverse, then use, okay, associative property, and after that you can use, okay, multiplicative inverse property, and finally, okay, inverse, okay, and then finally you need to use, okay, multiplicative identity property. Thereafter definitely you're gonna get, okay, proofs of this question, proof of this question, right? So let me explain again, okay, you will take this one. It's a very simple question. As we have done this question exactly, you have to do this question also, right? So let me tell you, okay, the steps. Firstly, you will multiply both sides by sin inverse, right? And then you will associate, okay? After that you will use the multiplicative inverse property, and finally you will use the multiplicative identity property, and at last you will get a is equal to b. The so simple question. All right, now I also think you have a problem. Okay, So very important. So don't ignore. If you ignore, definitely this question is going to ignore you, right? So go through this video and definitely you will be benefited. If you think it's useful, then you can share and you can ask your friends to go through this video also, right? Thank you very much for watching this video. Bye bye.